Welcome to Ask and Learn.
Okay, well, in this problem we have an ideal diesel cycle and we need to find the maximum temperature and the rate of heat addition. So just to simplify the problem, let's put here what is the diagram, the PV diagram for a diesel cycle. So this is P, this is V. The diesel cycle is represented by one transformation that is a constant volume, one transformation that is a constant pressure, and two isentropic transformations. So this is the first isentropic, and that's the second isentropic transformation. An isentropic was, as we know, means that there is no exchange, there's no heat exchange with the surroundings. Therefore, the heat enters here and leaves the cycle here. And we want to know what is the maximum temperature of the cycle and what is the input heat, the input rate of heat of this cycle. Well, the input rate is just the net rate, the network rate, divided by the thermal efficiency. Therefore, these are the two main things that we have to calculate in this problem. Let's begin with the temperature. Well, what is the maximum temperature of this cycle? Well, the maximum temperature is in the position 3. So this is 1, 2, and 3. So this point we have the maximum temperature. So the maximum temperature, T3, is going to be separated by, as we can see here, by an ideal gas transformation. So this is just T2 divided by V3, V2, and this here is just the cutoff ratio. So this is not really common to happen. We don't see that often in the problems, but this is the cutoff ratio, and we know what is this value. So therefore, what we have here is the temperature to multiply by RC, which is the cutoff ratio. Well, from here we have a problem because we do not know what is the temperature to. Therefore, let's calculate first that the temperature to is separated by, as we can see in the graph, an isentropic transformation. Therefore, this is T1, V1, V2 to the power of k minus 1. And V1 divided by V2 is just the compression ratio. So this is T1 R k minus 1, which is going to be 330 that multiplies 17 to the power of 0.4. And calculating this, we find that the temperature 2 is just 1025 Kelvin. Okay, so what is the maximum temperature? Well, the temperature 3 is going to be the temperature 2, which is 1025 that multiplies 1.3, 1.3, which gives us a maximum temperature of 1332 Kelvin. Okay, let's move on and calculate the input, the input rate heat. So we want the rate of heat addition. So this is Q dot in. This is going to be 140, which is the power, divided by the thermal efficiency that we do not know yet. So let's calculate the thermal efficiency. The thermal efficiency in this type of cycle is described, the diesel cycle, is described by 1 minus 1 divided by Rk minus 1 that multiplies Rc k minus 1 k Rc minus 1. Okay, so it's a huge equation. Therefore, the thermal efficiency is going to be 1 minus 1 divided by 17 to the power of 0.4 that multiplies 1.3 to the power of 1.4 minus 1 divided by 1.4 1.3 minus 1. Calculating this, we discover that the thermal efficiency of this diesel cycle is 0.6597. And finally, we can calculate the rate of heat addition. Therefore, the rate of heat addition is going to be 140 divided by 0.6597, which gives us a total of 212 kilowatts of power. Okay, so that's the rate of heat addition. And in here we have the maximum temperature. That's all. Thanks for watching.